Welcome to science class. Today we will learn about history of time and motion. Have you ever wondered how we decided that a second is exactly a second? Or why a car's speedometer can tell you how fast you're going at the exact moment you look at it? We live our lives by the clock, yet the story of how we learn to measure time, and the motion that happens within it, is a journey through thousands of years of human genius. From sinking bowls in ancient India to the precise swing of a pendulum, let's break down the physics of how we track the world in motion.
Since the beginning of human history, we have looked to the sky to organize our lives, defining a day by the rising and setting of the sun and a month by the changing phases of the moon. However, as civilization advanced, simply watching the sky wasn't enough, and we needed to slice the day into smaller, more precise intervals. The sundial was our first great leap, allowing us to visualize passing hours by tracking a shadow, yet time remained a prisoner of the weather until we turned to the elements, using the ancient Indian Gatika yantra, a sinking bowl, and the steady flow of sand in hourglasses to measure time regardless of the sun. In the 17th century, a new heartbeat for time was discovered when Galileo observed that a pendulum of a given length always takes the same amount of time to complete one full swing. This back-and-forth motion is called an oscillation, moving from the mean position to the extremes and back again, with the time taken for one cycle known as the time period. Scientific experiments reveal that this period depends only on the length of the string, not the weight of the bob, a predictable rhythm that became the foundation for mechanical clocks. This measurement of time allows us to define speed as the distance covered in a specific interval, calculated by the formula speed equals total distance over total time. While the international standard unit is meters per second, modern vehicles track this using a speedometer for instantaneous speed and an odometer for total distance. If an object covers equal distances in equal intervals of time, it is in uniform linear motion. But in everyday life, motion is usually non-uniform, where speed changes and we must use average speed to describe the journey. From the rhythmic swing of a pendulum to the vibrations of quartz crystals, our ability to measure these forces defines the modern world, serving as the language through which we understand not just where we are going, but how fast we are getting there.